We are on a collision course with our great neighboring galaxy, Andromeda. This massive system of several hundred billion stars is headed our way, setting the stage for a cosmic event that will fundamentally change both galaxies. The Andromeda Galaxy is historically crucial in proving that the universe did not revolve around us. Andromeda shattered the belief that the Milky Way is the only galaxy, expanding our understanding of the cosmos. Although much has been learned about Earth, advances such as the James Webb Space Telescope have yielded startling new insights into Andromeda that could not have been predicted a century ago. A little over 100 years ago, the Milky Way was seen as a faint band of light in the night sky due to limited technology that could not distinguish individual stars. Different beliefs about the Milky Way centered around its creation. This changed at the beginning of the 17th century when Galileo Galilei discovered with his telescope that the Milky Way is not just a group of lights, but a vast collection of stars, planets, and celestial bodies. Galileo's work disproved the notion that the Milky Way was the center of the universe and showed that it is a vast expanse of stars. In 1750, English astronomer Thomas Wright hypothesized that the Milky Way is a flat layer of stars, including our solar system. This theory was limited by the technology of his time. At the beginning of the 20th century, significant advances were made in astronomy. In the 1920s, Edwin Hubble used the 100-inch Hooker telescope at Mount Wilson Observatory to show that distant nebulae, including the Andromeda Galaxy, were separate galaxies containing billions of stars, fundamentally changing our understanding of the universe. The Andromeda Galaxy, also known as M31, has been observed since at least the 11th century, when the Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud. Al-Sufi's sharp sight allowed him to identify Andromeda without using telescopes, which is possible because Andromeda is one of the few galaxies that can be seen from the surface of the Earth without special instruments. Simon Marius only presented a description of the telescope in 1612, which laid the foundation for future astronomers. In 1764, Charles Messier catalogued Andromeda as M31, promoting its recognition. An important leap in the understanding of Andromeda occurred in 1864 when the English astronomer William Huggins studied its spectrum and found that it deviated from typical gas nebulae, a key observation. Andromeda is massive, estimated to be between 1 and 2 trillion times the mass of our Sun, and is thought to be about 10 billion years old, suggesting a complex formation history through the merger of smaller protogalaxies. Astronomers previously thought that Andromeda was significantly more massive than the Milky Way. Recent studies have revised these estimates and shown that the masses of both galaxies are much closer than previously thought. The physical dimensions of the Andromeda Galaxy are larger than the Milky Way, with a diameter of about 220,000 light-years compared to the 100,000 to 175,000 light-years of the Milky Way, underscoring its vastness. One of the fascinating features of Andromeda is its active galactic core, powered by a supermassive black hole with a mass between 110 and 230 million times that of our Sun. Observations with advanced telescopes, such as the Hubble Space Telescope, show two foci in the Andromeda Galaxy, the brighter of which lies slightly outside the true galactic center, suggesting strong gravitational interaction and the presence of a supermassive black hole. Andromeda is also rich in globular stars, estimated to be about 460, each containing hundreds of thousands to millions of stars. This abundance indicates Andromeda's history of galactic cannibalism, where Andromeda was swallowed up by smaller galaxies, increasing its stellar population and diversity. Recent observations indicate that Andromeda may be a transition from a typical spiral galaxy to a ring galaxy, a relatively rare type characterized by circular ring structures of bright young stars. Ring galaxies can form as a result of galactic collisions, or when a smaller galaxy passes through the center of a larger galaxy, making them unique among galactic structures. The imminent collision between the Milky Way and the Andromeda Galaxy is a cosmic event predicted to begin in about 4 billion years and continue for the next 2 billion years. This spectacular encounter culminates in the formation of a new supergalaxy nicknamed Milkomeda by astronomers and enthusiasts. The merger process is characterized by significant gravitational interactions and tidal forces that profoundly affect both galaxies. As the Milky Way and Andromeda approach each other, their immense gravitational forces begin to distort each other's shapes. This gravitational interaction pulls stars, gas, and dust from each galaxy, creating elongated tidal tails and initiating a series of complex gravitational interactions. The overlapping and blending of two galaxies is not a smooth process. Instead, it is characterized by chaotic and dynamic changes as their structures are gradually dismantled and renewed. One of the most dramatic consequences of this collision is the formation of new star clusters. When galaxies merge, the gas clouds within them collide and condense, leading to bursts of star formation. These stellar nurseries are regions where strong gravitational forces squeeze gas until it collapses and forms new stars. These newly formed stars are often merged, enriching the new supergalaxy with fresh stellar populations. However, gravitational perturbation causes changes in the orbits of existing stars. Stars that were previously in stable orbits around the center of the Milky Way or Andromeda are thrown onto new, more elliptical paths or ejected from the merging system. Some stars can be ejected into intergalactic space, becoming rogue stars no longer associated with any galaxy. This redistribution of stellar material promotes the formation of new cosmic structures and can lead to the formation of a complex network of stellar streams and clusters connecting the remnants of both galaxies. In addition to forming new stars and stars, the merger process also creates massive, complex structures in the new galaxy. Gas, dust, and stellar debris from both galaxies will mix and settle into new configurations, forming vast star-forming regions, spiral arms, and possibly new galactic features that are hybrids of both the Milky Way and Andromeda's original forms. These structures evolve over time under the influence of the new dynamics of the merged galaxy. The supermassive black holes at the centers of the Milky Way and Andromeda also play a crucial role in the merger. When galaxies merge, their central black holes eventually merge into a single, even larger, supermassive black hole at the core of the Milky Way. This merged black hole is a powerful source of energy and has a significant impact on the surrounding stellar environment, contributing to the dynamic and evolving structure of the new galaxy. Finally, the merger of the Milky Way and Andromeda will result in a completely changed cosmic landscape. The new Milky Way supergalaxy is a massive entity composed of mixed material from both protogalaxies. It has a rich tapestry of new star clusters, altered stellar orbits, and reconstructed galactic properties. This process of cosmic evolution driven by collisions and mergers shapes the future of the local group of galaxies and provides fascinating insights into the long-term dynamics of galactic interactions. The merger will lead to profound changes in our night sky and Earth's environment, potentially affecting habitats, biodiversity, and climate. However, this process will take place long after humanity is gone, as our sun will become a red giant and make our solar system uninhabitable in about 5 billion years. The merger of Andromeda and the Milky Way raises questions about the fate of our solar system and the formation of new galactic structures. The cosmic interaction will create a new galactic environment with potentially habitable zones for possible life forms, although it will be very different from what we know today.
The Milky Way galaxy is a testament to the dynamic and ever-changing nature of the cosmos. The collision between the Milky Way and Andromeda, which is expected to take place in about 4 billion years, will be a spectacle of cosmic proportions. It marks the culmination of a gravitational dance that began billions of years ago when these two massive galaxies began their inevitable approach to each other in the vastness of space. As the merger progresses, one of the main phenomena that astronomers expect is a change in the spiral structures of both galaxies. Currently, the Milky Way and Andromeda are spiral galaxies characterized by their prominent arms extending outward from the central storm. These spirals determine the rotation of stars and gas around a central core, creating the distinct patterns visible from Earth. But when the galaxies converge and their gravitational effects intertwine, these spiral structures undergo significant changes. The mutual attraction between the Milky Way and Andromeda distorts their shape, pulling and stretching their spiral arms into elongated tidal features. These tidal tails are composed of stars, gas, and dust that have been pulled away from their parent galactic disks, creating a chaotic but mesmerizing picture of the cosmic landscape. The collision also triggers powerful bursts of star formation in the nascent supergalaxy. The interaction of gas clouds in both galaxies causes them to contract and heat up, causing the formation of massive bright star clusters. These clusters become nurseries for young stars, whose energetic radiation illuminates the surrounding cosmic dust and gas, giving rise to new stellar populations. The merger process affects not only the appearance of galaxies, but also their internal dynamics. The gravitational interaction between stars and gas clouds causes their orbits and velocities to rearrange.